everyone. Welcome. Gaurav, we are live.
Hello, everyone. Thanks for joining in. My name is Gaurav Seth, and today I will be joined by my colleague Tulika. And over the next hour, we are going to talk about how to add generative AI capabilities to your .NET web application and then deploy them and host them for Azure App Service. So before I begin, a quick look at the agenda. So we are going to talk briefly about app service benefits, and then I'm going to showcase all about the AI assisted migration and modernization. Then we'll talk about a couple of use cases around how to use generative AI capabilities for your classic .NET application and for your modern .NET application. So, a quick call out about the benefits of why you should be deploying your web applications that utilize generative AI capabilities on app service. So, first and foremost, you could just focus on your AI app and not worrying about the underlying infrastructure. I mean, you could release your applications way faster with inbuilt CI/CD integrations. You can scale your web applications using multiple options that we provide. It could be manual scaling, rule-based scaling, or automatic scaling. Now you could again go ahead and integrate or build and deploy your web applications using Azure OpenAI based on a language or a framework that you're familiar with. And also when it comes to security, which is foremost for any web applications these days, I mean, you could use things like network isolation, integrate with API management, use managed identity, etc., to secure your AI apps. And then when we talk about more advanced scenarios, we are again looking at using the sidecar pattern that we recently, it's currently in public preview for app services Linux, and you could use advanced concepts like vector caching. And finally, you could also look at inbuilt support for Azure Copilot, which helps you diagnose and solves problem with your app service, with your web apps on app service. So moving ahead, what's the demo scenario we are looking at today? So you basically have a web app which is on-prem. How do we modernize that web application and then deploy that onto app service? How do I use the freely available migration tooling to identify changes that would again enhance the successful journey for your web application over to Azure App Service? How do you take advantage of some of the features that are available on App Service? And finally, how do I introduce generative AI capabilities on to either an existing .NET web application or to a new web application that you may build on a modern .NET framework? And these are primarily the two scenarios that we'll be talking today. It's going to be the goal number one: modernize a web application running on IIS web server, use migration tooling to migrate my web application. And once I've done the migration, how do I introduce generative AI capabilities? The second goal is that I am building a modern .NET web application. And again, how do I introduce more advanced concepts like vector caching, or trying to talk about, how do I integrate OpenAI SDK onto my modern .NET web application? Now, before I get into the demo part, here are some of the tools that are available for you that help you with AI assisted modernization and migration of your web application. So again, if you are looking at sort of modernizing and migrating your entire data center, you can utilize the inbuilt experience with Azure Migrate. That once you've done the initial configuration with a virtual appliance for Azure Migrate, we help you discover your entire IIS or .NET based infrastructure. So we basically let you discover every individual .NET web application in your data center. Once that's done, you could again go ahead and do an assessment for all of these individual web applications. Now, in this scenario, the assessment is primarily based on the configuration of your web application. So what that means is, what's the port that your web application is hosted on, what's the kind of authentication, to give you some example. And finally, you could even perform a bulk migration where we let you package all your code and config and then deploy on individual web applications in app service. Similarly, if your scenario is about a single IIS web server, or if you're looking at a scenario where your web server is behind multiple layers of security and you may not even have internet access available on your virtual machine, you could look at using the PowerShell scripts. Now, when it comes to PowerShell scripts, again, behind the scene, we follow pretty much the same concept where we let you discover all web applications on a single server. We let you assess these web applications, and then you could either migrate off that VM if you have internet access, or you can just zip the content and config, copy it to a virtual machine which has internet access, and then go ahead and migrate. And finally, the demo scenario that I'm going to cover today, you could be using Visual Studio. You can just go ahead, download a extension from the marketplace, and then we let you do a source code analysis, and then you can go ahead, make the changes as suggested, and finally migrate your web application. So before I move into the demo, it's always a great idea to look at the example architecture or the deployment that we have for the classic and the modern .NET web application. So here we go. We have a web application that's hosted on your local server. You go ahead and do a source code analysis using the extension on Visual Studio, and then you finally migrate your web application. Now, the important point to note here is that the entire deployment, once you do it on Azure, is secured. It runs inside a virtual network, and we are using landing zone accelerator for deployment. Again, just a quick note, landing zone accelerators are basically, it's like a templated deployment where we follow standard best practices when it comes to isolation, security, and things. And again, the entire, I should say, the flow of data or the conversation between your web application and the Azure OpenAI endpoint is secured using managed identity. Similarly, what are the ways that you can interact with a generative AI, or you can infuse generative AI capabilities into your application? You could either do REST APIs, or you could use the SDKs, which are available for different languages and frameworks that you wish to use, or it could even be the OpenAI SDK, which is again even works with GPT 4.0, or you could look at using the higher level LLM frameworks. And again, this is not an exhaustive list. These are some ideas. You could be looking at LangChain variants or using semantic kernel. And again, how would I go ahead and call a generative AI or an OpenAI endpoint from an existing .NET web application? It could be using the SDK. It could be using semantic kernel, as I said, and that's the exact demo that we'll be talking about. And this is the final slide before I move into the demo. So again, the idea is, for the second demo scenario that my colleague Tulika is going to talk about, you have an app service. I mean, in this case, it is a modern .NET 8 web application deployed to App Service Linux, and then it basically utilizes a Sidecar pattern where we let you build a vector cache, and then it goes ahead and communicates with the OpenAI endpoint. With that, let me go ahead and jump straight into the code. So this is my classic .NET 5 web application. framework application that I was talking about. And the scenario is this is the web application to go ahead, modernize, and migrate using the AI assisted toolkit that I was talking about. Now, the idea is that you have Visual Studio, you go ahead to the marketplace, this toolkit for .NET. Once you download that extension, you to Azure. Once you click on re-platform to Azure, it gives you this screen where you can, if you have already done this in the past, you can either open the report or you can simply go ahead and start a new report. Now, it will ask you what application to. In my case, I'm going to say App Service Windows. It will give you a list of all the projects within the solution. For the sake of simplicity, let me go ahead and just select a single project. Now, in addition to the source code and settings, if you want, you can also go ahead and do the analysis for your binary dependencies. And if you want, even include that file over here. Click on Analyze, and within matter of seconds, we'll give you like a nice dashboard which tells you the number of projects that we analyze, how many issues and incidents that were seen in the project that we have analyzed. Now, if I get into the individual issues, we try and give you a level of mandatory, optional, and potential. Mandatory is something that it is highly advisable that you should fix, because once you migrate your web application to app service, those are the kind of changes or breaking changes because of which your web application may not even load or may not even work properly. When it comes to potential severity levels, which we would again say it's advisable to just fine even after migration, and maybe you can take time to this is just a demo scenario I'm talking about, but from a real life production web application scenario, it's going to be like you use one of the assessment tools that I previously talked about. You go ahead and run assessment. Basically, you discover your web applications, you do an analysis. It's like step one, step two, and finally, whatever issues are encountered, you go ahead and make those code changes. Check in into your CI/CD deployment. Having said that, you can even do a deployment straight out of Visual Studio. That's the use case. So there are multiple ways you can do the same modernization and migration flow. Let's look at couple of the issues over here. So as we all know that it is very, very common for us to use an integrated .NET web application, especially the framework application. And now when you go ahead and migrate this web application to app service, you don't have the concept or you don't have the support for integrated authentication on app service. So idea is that you can either use the Enter ID based authentication provider that we provide for app service, or you could do it based on an SDK. Now, the other great benefit is, one, we do the source code analysis over here. The other is Copilot. Now, what's going to happen here is, based on the issue that we have identified, the Copilot will go ahead and give you the analysis and the steps that you can take, even with the example that you can integrate into your web application and then go ahead and make the changes. So that in this case, if I go ahead and see, what I'm seeing here is that you have set the authentication mode to Windows. So that's what you can do. Integration, it could be within SDK, or you could even directly go ahead to your web application post migration and and then set up this authentication provider. Similarly, if I look at that, there has been optional severity data.sql client NuGet package. It would just work fine once you deploy your web application. But the suggestion is to go ahead and upgrade this NuGet package, because that's where, if you go ahead and upgrade to Microsoft managed identity, and that's the package that's going to receive more and more updates as we move forward. So again, let's go ahead and ask the Copilot in this case. So now you get an analysis. Why should you even consider upgrading? How do you upgrade? How do you include the package reference? So you need to go ahead and install this new, include this package in your code. And then there is this example code block that how your code is exist, or how it is looking before and after. So how your existing code is and what are the changes you should be making. And here is the example code update. So now what I've done in the interest of time is I've already migrated my web application to App Service. So that's how and make changes to your source code before you even migrate your web application to App Service. So that's the power of AI assisted modernization and migration for your web application. Now, what I've done in the
Gaurav,
interest of time is I've already gone ahead. Yeah.
I'm sorry to interrupt. We've been having some trouble hearing you with your audio, and we had an idea. Perhaps we could give it a try. Want to try stopping your video so that the only thing that we're transmitting is audio and see if that might help? All right, folks, we'll give it a try. Thanks for your patience.
Oh, is it better now? Am I audible? So sorry. I mean, I didn't even realize because I'm on the screen presenting, so I don't get to see the comments.
It's all good. You sound a lot better. Sounds much less choppy.
Okay, great. So I don't know what part I missed, but maybe I can just do a quick summary for the interest of the audience. So what I did was I just went ahead and downloaded extension from the marketplace, installed that onto my Visual Studio, and from the source code, I basically started the analysis of the source code, and that's the report that I get. Now, what I see here is the list of issues that were reported: mandatory, optional, and potential. Mandatory is something that you should definitely be fixing before you deploy your web application. And what I also showcased is how easy it is for you to go ahead and Copilot chat extension. And if I go ahead and ask the Copilot, that's the kind of response I get. So it will tell you what's the package you need to use, what's the changes you need to make. The other example here is if I am using, I won't say a deprecated, but an old and say ask Copilot, and then you again get recommendation in terms of what's the latest package you should be using, why you should be using this package, and what are some of the code changes that you would be required to make in terms of before you deploy your web application to App Service, so that you have a much higher chance of a successful. What I've done is I've already migrated this web application. And as you can see, once I migrated my web application, again, I can go ahead and make a lot of changes. I mean, in terms of configuration to Azure App Service. So you could be defining your environmental variables over here. You could define your connection strings so you can move them out from your web.config over to Azure App Service. And remember, I was talking about authentication. I can even go ahead and set authentication for my web application. In my scenario, I have set the authentication against my Microsoft Entra ID. So yeah, I mean, you could do all of these things. And if I'm experiencing any kind of issue with my web application post migration, I can even use the whole diagnose and solve problem experience. If I have an issue with availability, or if I have any issue with my configuration, I can go ahead and use those. Now, this is the web application I was talking about. I have gone ahead and migrated this web application. Now, this is my classic framework based web application. I should say, nothing extraordinary on this web application. The only change that I made, or the code that I wanted to showcase, is what I've done is power of Azure OpenAI. What I have done is I've introduced this new option to say chat with AI assistant. I can just put a query over there and say, suggest a bag for students. Once I submit, I get the response back. Now, this is a simple but a powerful example of generative AI capabilities into an existing framework based. Now, what are the code changes that I made? So this is my standard ASPX page. What I've done is I've introduced a new function. It's just a jQuery function. Takes the text controller. And if I talk about my chat controller, what I've done here is I have included a couple of NuGet packages, the Azure AI, OpenAI .NET SDK. So remember, this is the .NET client SDK that I'm using with my framework web application. I have gone ahead and created all the properties over here, and all of these web.config settings. What I've done is I've actually moved them over to the environment variables and not have them in my web.config. I go ahead and initiate the OpenAI client, and then finally in my chat controller, what I am saying is that I want to use the default Azure credentials. Now, in this scenario, when I say default Azure credentials, you could either be using managed identity or a system-based identity. Once you go ahead and use the default Azure credentials, you can use either credential to secure your web application. Once I've done that, I go ahead and use the chat completions API. What I do here is when I make my connection, I send a system message. So what I'm doing is I am doing a chat request, and then I would get a chat response back. Now, in this scenario, as you all know, basically creating a prompt, and in this scenario, my prompt is that you are an employee of a store that provides product recommendations based on the user query, and I just want to limit the recommendations to a single product. I've said just the max tokens. I get the response back, and then I relay the response back from my chat controller over to the page. And that's what you just saw. So this is how simple it is for you to go ahead and use the open AI packages, the NuGet packages, go ahead and create this, and then integrate generative AI capabilities into your existing framework applications. With that, I'm now going to hand over to Tulika, who's going to talk about how to infuse generative AI capabilities into a modern .NET 8 based web application.
Thank you, Gaurav. So Gaurav has kindly covered all the slides, which means I just get to do the demos, which is always nice. So I'm Tulika. I am a product manager with Azure App Service. And today I'm here to talk about one of the most exciting features I'm working on, which is Sidecar support for Linux App Service. I'm going to walk you through some demos which shows you how to use the Sidecar. And we'll be ending with what I hope is an exciting demo of adding AI capabilities into your application. Anna, could you just bring up my screen now, please? Okay, so I'm going to take the same application that Gaurav mentioned, the DevShop application, and I'm going to now talk a little bit about Sidecar. So sidecar pattern is an architectural pattern which allows you to have auxiliary services with your web application such that they run together with the web application. So these auxiliary services could be things like logging, observability, caching, and I'll also show you how you can use AI as an auxiliary service or a sidecar to your web application. We launched the sidecar pattern at Build this year, and we've been working very hard to get some integration and some scenarios for you. And I'm going to show you the first scenario where I'm taking the dev shop that Gaurav showed, and I'm going to try and integrate Datadog, which is an observability partner for us, and see how we can have the observability data from our dev shop flow into Datadog. So here I've got the same application that Gaurav had shown. There is one difference in this application, and the difference is that I have taken the DevShop application and created a container out of it. Now, why did I do that? That's because right now the sidecar pattern is available for container-based apps. We are working to enable it for code-based apps as well, and you should see an update about it real soon. But right now, we'll go with the container-based app. So I've just taken the code that Gaurav migrated and put it inside a container. Now I want to run Datadog with it. And the way you do the integration is you go to the deployment center, and you will notice that we now have a new containers tab. In the containers tab, you can add up to 4 sidecar containers. So here you can see the main container, which is the DevShop application that I just created a container out of. And I have added another container, which is the Datadog container. Now, Datadog is an Azure native ISV service partner, and we've been working with them for the last few months to enable such integrations. What this really means is that the container image has been provided by Datadog, and all I've really done is taken the container image and pushed it into my own container registry. I've also made sure that I have enabled manage identity, and I'm using a user identity over here just so that I'm following all the security best practices. And then I specify things like the image tag, and the port for the sidecar container. And after that, I have to do things like add some environment variables. These environment variables are things like the API key for Datadog, what kind of data do I want Datadog to consume, and that's it. I don't have to make any changes in my application, and that should just work like that. So just to show you, I've run this application over here. As you can see, it's exactly the same application that Gaurav showed. But if I now go to Datadog, you will see that right at the outset, it has found that I've registered a new service called the DevShop Datadog. I can go to the service page of this service, And I can look at some metrics which are related to the service. So I can look at the number of requests which have flowed in, any errors if it was there. I can also look at the P95 latency and I can figure out if there are some really slow requests. Now with Datadog, one of the things that I really like is the Log Explorer. So if you go to the Log Explorer, and you can see that, oh, it's just 15 minutes. Let's change it to an hour. All the logs from my service has been multiplexed into Datadog, which means that I can now do a search on the logs. I can group the logs based on certain patterns. I can even configure watchdog alerts on it and get notified anytime there is an anomaly in my application. We think that this is a really powerful way to add things to your web application. So without rewriting any kind of code, we manage to have observability integrated. If you want to see how this works, I have a blog over here. Please try it out. And Anna will post the link for the blog in the chat so you can try it out and see how to set it up. Now, Datadog is not the only partner we've been working with. We are also working with other Azure native ISV service partners. So you will see another blog, which is for Dynatrace. We, in case that's the observability partner that you want to use, we have, the steps over here on how you can integrate that. We're also working with Elastic Observability, and we'll have a blog for that real soon. So this is all about giving you the choice. Now, I know we promised AI, but before I move into AI, I'm going to show you another use case for sidecars. This use case is adding some kind of caching ability to your web application. Now, I've taken the web application that you get in Visual Studio by default when you create an API app. So by default, it creates the weather forecasting app. So I've taken the weather forecasting app, and what I want to do is that I want to use a Redis sidecar with the web application. So I want to implement caching using a Redis sidecar. So I've done exactly the same thing. You can go to the deployment center and go to our new containers tab, and I've added Redis as a sidecar. You will notice some differences here. Firstly, notice that my image is now coming from Docker Hub directly. What it means is that I'm using the Redis public image. So here you can see the registry URL, which is from Docker Hub, and I've specified the port for Redis. This is the default port for Redis, which is 6379. And that's it. I have some little bit of code in my application. So if I go to my application over here, you see that I have a get weather forecast where I'm trying to retrieve values from the cache. If the cache is not null, I go and retrieve values from the database. Let's see this in action. So this is an API. I'm calling the weather forecast. Let's go ahead and run this a couple of times. I've printed some helpful messages in the logs as well. So we can go and look at logstream for my application. And if you look at logstream, you can see that we have the data coming from the logs. So this is how you can integrate caching ability using sidecars into your web application. Now let's move on to our AI demo. Oh, by the way, if you wanted to see how this works, we also have a blog which tells you how you can set up your environment, and it also has the code for it. So if you just want to run it and play with it, and Anna will again put in the link for the blog in the chat so you can definitely play with this. Now let's move on to the same DevShop application, and this time we are going to add the generative AI capabilities into this application. Now, the first thing I will point out is that this is a code-based app. So you can see that I am running .NET Core. My publishing model is a code-based application. I'm still going to use a sidecar. However, so Sidecar does work even right now for code-based applications. It's just that we are still working on the portal interface for it, so that's not available. But you can absolutely use sidecars with your code-based apps using ARM templates. So I've got my dev shop over here, and my aim is to add AI capability. So I'm running this application. As you can see, it's the same application. I can go somewhere and I can click over here. It's similar to the chat assistant that Gaurav showed you, but this time this chat assistant is slightly different. It's different in the sense that I want this chat assistant to work on my data. So I want it to work on the data I have in the SQL database. The other thing that I want to do is that I want to, if you've already asked it some questions and you've generated some responses, I want to store it into a vector cache locally on the instance, so the next time somebody asks a similar kind of question, they can retrieve it from the vector cache. So let's click on chat with AI assistants, and I will say, so now I'm asking it about products in my database. Tell me more about the printed trousers. There's something about live streaming that you forget how to type in. So when I hit submit, one of two things can happen. One is that it can say, oh, there's nothing in the vector cache, and it can go to OpenAI and try to retrieve the results from there. Or it can find the result in the cache and return back very quickly. So here, the fact that it has returned back really quickly means that it has found the question and the answer in the cache and got back from the cache itself. If I hit submit over there, I'm guaranteed that this is going to come from the cache, and you can see that it has come much faster. I can keep on asking more questions like, how do I pair the printed trousers because I want to look all chic? And I can hit submit, and it's going to go ahead and keep answering that. I also want to point out that we are maintaining the chat history as well. And we'll look at the code to see how we are achieving this. So let's go ahead and start looking at the code. All the code that I was showing over here is in the product detail controller. So here, the first thing, as you can imagine, that we have to set up a number of things. Now, my first requirement was that all my data resides in the SQL Server database. And I want the chat to work on my data and not just go off in the internet and retrieve something. To do that, I have created an index on my SQL Server that's called the Azure SQL Index, and passed that index onto Azure AI Search. So when somebody asks it a question, it's going to go to AI search, but the AI search is using the pre-populated index to search for the product. So here you can see that it takes the user message and it goes ahead and does the search in the index, and it's retrieving the product details like product ID, name, and description. The next thing we want to set up is the quadrant database. Now, quadrant is a vector database, and we are using quadrant over here as a vector cache. So if you ask it a question, we want to store it in the cache, so the next time we can retrieve it from the cache and it'll be much faster. The thing that I want to point out over here is the fact that notice how my quadrant endpoint is localhost. And you might think, oh, how are you calling something on localhost? And that's because my sidecar is in the same network namespace. So my quadrant is running as a sidecar, and my sidecar is in the same network namespace as my main application, which means that the main application and the sidecar can talk to each other on localhost. I also want to mention over here that the difference between the main container and the sidecar container is HTTP requests can only go to the main container. So from the outside, if you want to ping anything, you can only ping the main container. You cannot ping the sidecar. So here my quadrant is running as a sidecar to the main application, and we can connect to it on localhost. So we've set that up. Now for my chat capability over here, I'm using Semantic Kernel. Semantic Kernel is an open source SDK which allows you to connect to different frameworks, AI frameworks, as well as models. So here I'm using Semantic Kernel to connect to Azure OpenAI, and there are two models that I'm connecting to. One is the chat completion, because that's what I'm using to do the chat, as the name suggests. And the second that I'm using is text embedding. Remember, I said that I'm storing the data in the vector database, but before I can store it into the vector database, I need to vectorize the data. The vectorization to and fro is being done by the text embedding API. We showed the chat history, and this is how I'm maintaining the chat history. I've taken a very simplistic approach for chat history. I'm just storing it into the session state, and that's it. I'm retrieving it from there. Obviously, this is a very simplistic approach, and if you want a more distributed chat history, you might look at some other caching providers which can create the entire session state. Finally, I create the prompt template. This is similar to what Gaurav said. The prompt template defines how your chat assistant is going to behave. And the thing I'm specifying over here is I'm using the GPT-3.5 Turbo model for my chat completion. Now that we are all set up, all we need to do is get the chat response. So when the user sends in a message, the first thing we do is go ahead and search the vector cache and check if we have, the question and the answer in the vector cache itself. If yes, we return back and call the chat completion API to do the generative AI and generate a response for it. If we don't find it in the vector cache, we will do the Azure AI search and retrieve the details about the product, and then again pass it to Azure OpenAI to generate the response. Once the response has been generated, we stream the response one chunk at a time so it appears on the client, and we take the response and add it to the session state. So this is where we are maintaining the chat history, and finally we go ahead and store it into my vector cache. We are using the memory plugin provided by Semantic Kernel to store the question and the response into the vector cache. So the next time we come around, we can retrieve it from the vector cache. So this is how you can use OpenAI into your application. Now, this is one example. OpenAI, as you know, is a large language model, and it's extremely powerful for scenarios like this. However, we also have the option of small language models, or SLMs. SLMs have lesser parameters than large language models, and their training data is also lesser. But it also means that you can train a SLM in much faster. You can use it more efficiently for inferences. And the best part, in my opinion, is that you can also run it on CPU-based machines, and therefore, you know, presumably can run it with lesser cost. So I'm going to show you another example where I'm going to add generative AI capability into my application, but this time I'm going to use a SLM for it. So I've created another application. Again, it's a very simple application. It's a fashion assistant, so it's like almost like customer service for my store. I have my data now residing in markdown files, which I've just copied into this fashion assistant application, and I want to go ahead and run a SLM to answer some questions from the data that I've already stored there. So first of all, I'll show you how this works. Again, going to the deployment center, you will see that there is the main application. The main application is extremely simple. It's a Python Flask application. And I've added the SLM as a sidecar. Now for this SLM, I'm using Phi 3, and for Phi 3, I'm using the ONNX runtime model. So what it lets us do is that it lets us run SLM on CPU-based workloads. And you can see from here, App Service is running on one of our premium instances, which is a CPU instance and not a GPU instance. Oh, wow, that's taking too long. Okay, so while this is just loading, let's go ahead and browse this application. Here, I wanted to show you that we are running on a CPU-based workload and not a GPU workload. So let's go ahead and run this application. We could ask it a question like, what's your exchange policy? And say, ask me anything. What it's going to do is find the result in a in-memory vector database that I'm using, and based on that, using the SLM, it's going to generate a response for it. So let's go and look at the code for this. So first of all, I want to point out that all my data is actually in this folder called store docs. So you can see there is a folder called store docs, and I've added some markdown files in it. So that's all the data in my store. I can show you the exchange MD. That's the exchange policy I asked, which is just some policy documents I created. Now going to the controller, the first thing that I do is in the constructor, I am loading the model. Now, in this case, Phi 3, at least the ONX model, is actually an offline model, which means that it resides on the file system. So here, the way I'm loading the model is simply referring to it from the file system. I'm also initializing a vector database. So all the data that I showed over here, I'm loading it into the vector database. I'm using a basic in-memory vector database. I could have just used, a distributed vector database like Cosmos DB or even Quadrant, but just for simplicity, I'm using an in-memory vector database. So I'm going over here, initializing my vector database and loading the documents there. Let's go ahead and look at my load function. So this is the function which loads all my documents into my vector database. Again, very simple. I'm doing basic text chunking based on paragraphs and just putting it into my vector. Once I've done that, the real work is happening in this new API that I've created called Generate Response. So in the Generate Response, we are getting the user prompt, which is whatever the user sent, and going and first doing a search in the vector database, getting a result. And based on the result, I'm passing that result into the user prompt. And then I'm calling a method called Generate AI Response. And you can see the Generate AI response where the actual generation is happening. So we are initializing our tokenizer, passing it the search options, and then running it in a loop as we are generating tokens. I'm generating it one token at a time, and as soon as I generate a token, I return back to the calling function, which flushes out the token. So you see all the text, come in a streaming manner. Let me show you the client code real quick. As I said, the client code is very simple. It's a Python Flask app. And that's one of the power of Sidecar, that you could have, a front end and a back end, if you will. And the front end could be in a different language and the back end could be in a different language. So here you can see that I've specified the API URL. Again, the same thing I mentioned earlier. It's running on localhost because it's running as a sidecar and can talk to each other on localhost. And that's the method I had defined. And then finally, I set up a route and I go ahead and put in a text, and I'm returning the response in chunked manner and showing it as streaming code. So this is how you can add generative AI capability into your application via SLM. If you want to try this out, I have several blogs, and Anna is going to put the link in the chat, which will tell you how you can set this up and run this. And in fact, you can change out the MD files that I have and have your own data and see it work with that. So this brings me to the end of the demos that we have for today. In today's session, we talked about how you can first take an application which is on-premise, modernize the application and migrate it to Azure App Service. We looked at adding generative AI capabilities even in your .NET Framework app, but then we moved on to .NET Core and we talked about how you can use things like semantic kernel to add generative AI capabilities to your .NET Core app. And then we looked at the sidecar pattern where we looked at a number of scenarios like observability, caching, and SLM to add auxiliary services to your web application. So this brings me to the end of our session. I hope you enjoyed it. If you have any questions, we will hang around for a couple of minutes so you can post the questions and we would be happy to answer it. Both Gaurav and I are on LinkedIn and our socials will be shared with you. So in case you have any questions or want to contact us, we would be happy to answer them. Thank you.
Thank you, everyone, for joining. Thank you to our speakers. To learn more about this series, watch past episodes, and register for future sessions, you can follow the link at the bottom of the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. Today's event code is 23657. We'll see you at the next one.